So far, we've talked about agentic patterns that primarily involve orchestrating interactions between language model and managing the flow of information within the agent's internal workflow, like chaining, routing, parallelization, and reflection. However, for agents to be truly useful and interact with the real world or external systems, they need the ability to use tools. The tool use pattern, often implemented through a mechanism called function calling, enables an agent to interact with external APIs, databases, services, or even execute code. It allows the LLM at the core of the agent to decide when and how to use a specific external function based on the user's request or the current state of the task. The process primarily involves first, tool definition. External functions or capabilities are defined and explained to the LLM. This includes the function's purpose, its name, and the parameters it accepts, along with their types and descriptions. The next is the LLM choice. The LLM receives the user's request and the available tool definitions. Based on its understanding of the request and the tools, the LLM chooses if calling one or more tools is needed to fulfill the request. The third is the function call generation. If the LLM chooses to use a tool, it generates a structured output, often a JSON object that specifies the name of the tool to call and the argument or parameters to pass to it, extracted from the user's request. The fourth is the tool execution. The agentic framework or orchestration layer intercepts this structured output. It identifies the requested tool and executes the actual external function with the provided arguments. The fifth is the observation or result, where the output or result from the tool execution is returned to the to the agent. And finally, we have LLM processing, which is optional but is mostly common, where the LLM receives the tool's output as context and uses it to formulate a final response to the user or choose on the next step in the workflow, which might involve calling another tool, reflecting, or providing a final answer. This pattern is fundamental because it breaks the limitation of the LLM's training data and allows it to access up-to-date information, do calculations it can't do internally, interact with the user-specific data, or trigger real-world action. Function calling is the technical mechanism that bridges the gap between the LLM's reasoning capabilities and the vast array of external functionalities available. While function calling aptly talks about invoking specific predefined code functions, it's useful to consider the more expansive concept of tool calling. This broader term acknowledges that an agent's capabilities can extend far beyond a simple function execution. A tool can be a traditional function, but it can also be a complex API endpoint, a request to a database, or even an instruction directed at another specialized agent. This allows us to envision more sophisticated systems where, for instance, a primary agent might delegate a complex task analysis to a dedicated analyst agent or query an external knowledge base through its API. Thinking in terms of tool calling better captures the full potential of agents to act as orchestrators across a diverse ecosystem of digital resource and other intelligent entities. And frameworks like LangChain, LangGraph, they provide robust support for defining tools and integrating them into agent workflows. On the canvas of these frameworks, you define the tools and then configure your agents to be aware and capable of using these tools. Now we'll see some practical application and use cases. So the tool use pattern is applicable in virtually any scenario where an agent needs to go beyond generating text to perform an action or retrieve specific dynamic information. We'll see some tool use cases here. The first is information retrieval from external sources. We're accessing real-time data or information that is not present in the LLM's training data is our main focus. A use case that can be considered here is a weather agent. So the tool that can be used in this agent is a weather API that takes a location and maybe returns the current weather conditions. So the flow in this particular case can be whenever the user asks what's the weather in a certain city, LLM identifies the need for the weather tool, maybe calls the tool with that particular city name, and then the tool's return data, and LLM formats the data into a user-friendly response. The next use case can be interacting with databases and APIs, where we do queries, updates, or other operations on structured data. A typical use case can be considered as an e-commerce agent, where maybe the tools can be API calls to check the product inventory, get order status, or process payments. And the agent flow could be something like this, where user asks maybe is some product in stock or not, and then the LLM calls the inventory API, tools basically return the stock count, and then LLM tells the user about the stock status. The third application can be doing calculations and data analysis, where an agent could use external calculators, data analysis libraries, or statistical tools. A typical use case can be considered as a financial agent, where the tool inside it could be a calculator function, a stock market data API, or maybe a spreadsheet tool. And the flow could be something like this. Whenever the user asks like what's the current price of a certain stock, and then calculate maybe the profit, if I bought maybe 100 shares at maybe $150, the LLM would call that stock API, get the current price, and then calculate, and then basically call the calculator tool to get the result and then format the response. Next application could be in sending communications, where it could be used to send emails or make API calls to external communication services. A typical use case could be considered as a personal assistant agent, where email sending API tool could be used. The agent flow would be something like this. Whenever the user says like send an email to someone about the meeting tomorrow, LLM basically would call that email tool with the recipient, subject, and the body extracted from the request. The fifth one is executing code, basically meaning an agent could run code snippets in a safe environment to maybe do a certain task. A typical use case could be considered as a coding assistant agent, where a tool could be used which would be a code interpreter, and the flow would be something like this. Maybe user provides a certain code snippet and then ask what does this code do. So what the tool would do is basically LLM would use that interpreter tool to run the code and then analyze its output. And the final one could be like controlling other systems, basically interacting with smart home services, and then other connected platforms. And a typical use case could be a smart home agent, and then a simple tool there could be an API to control the smart lights. And the user could say maybe turn off the living room lights. The LLM would call that smart home tool to turn on the light with the command and then the target device. So tool use is what transforms a language model from a text generator into an agent capable of sensing, reasoning, and acting in the physical world. Now we'll see a code implementation of this particular tool call in LangChain. So the implementation of tool use within the LangChain framework is typically a two-stage process. Initially, one or more tools are defined, and then these tools are bound to a language model, thereby granting the model the capability to generate a structured tool use request whenever it identifies that an external function call is required to fulfill a user's query. So let's go for the implementation and then see how we can implement tool call in LangChain. Now we'll see the implementation and then explain some new concepts in this implementation after we've done this. So from .env import load.env. This will load our API keys from .env file. Then from LangChain underscore grok import chat grok. From LangChain dot tools import tool from LangChain from LangChain dot agents import create agent. First of all, I'm going to define my LLM, and my LLM will come from ChatGrok. I'm again going to use the same model that I've been using since past many videos in this series, which is the Llama model. Then I'm going to define few tools here. The way to define a tool is mark it using @tool, then create a function for it. So the first function is multiply, integer, b integer, and then it will again return an integer. We'll write a docstring for this. So what this basically does is multiply two numbers. I can directly return a into b. Then I'll add one more tool here, which will be def add a integer, b integer, and it will again return an integer. So add a docstring, add two numbers, and then return a plus b. So these are the custom tools that we will provide to the LLM for our tasks. So I have two tools, add and multiply, which I'm going to keep it inside a list. Then what I'm going to do is I'll write a system prompt. The system prompt will say I'll do it a multi-line string. You are a helpful AI agent. Use tools when necessary. If no tool is required, answer directly. So this will be my prompt, system prompt. Now instead of directly invoking the LLM, what I'm going to do is I'm going to create an agent. So I'll call this create agent function from LangChain.agents. I'll define my model. My model will be the LLM that I have implemented here. Then I will also provide the access to tools that it has, these particular tools, and then I'll provide a system prompt. Now this will be our system prompt. Now finally what I can do is I can run this agent here. So for a continued conversation, I'm going to do LangChain basic agent, also print type exit to quit, and then add a line break here. Now let me run an infinite loop. While true, I'll ask user query here. Further, I'm going to insert a condition to break out of the loop. So if user input dot lower equals to exit, then I'd like to break out of the loop, or basically end the conversation. Now if there is a genuine user query, then I would like to invoke the agent. Response equals to agent dot invoke, and while invoking the agent, I'm going to create messages. Now this will be a list of first of all, I'm going to add a human message. So role user, and content will be user underscore input. Now finally, if I want to print out what exactly the AI response is, I can simply do AI response, and then append it with response. Inside response, I'm going to go for messages. Inside that, I'm going to go to the last message that I have and then print out its content. Else, what we can also do is we can also check out the entire response that we get from the agent. So AI agent debug mode, and here what I'm going to do is I'm going to print out my response and finally insert 2 blank lines here. So my code implementation is now complete. I can directly run this code, and while I'm running this code, I'm going to explain what did I exactly do here. So Python 12 agents, 1 tool calling agent.py. The project is already running, but at first I'd like to help you understand tools here, because tools are what a language model or tools are basically those components that convert a language model into an agent. So by default, a language model can only generate your text content, right? So it cannot reliably do calculations, call functions, or interact with external systems. And that is where tool comes in. So a tool is a simple Python function that we expose to the language model, so the model can choose when to use it, which tool to use it, and what arguments to pass. So in our code, we have implemented tool using this particular @tool decorator, and first we've created a multiply function. It basically takes in 2 integer and then returns their product. Then we've also created an add function that adds 2 numbers. The important part here is not the math, but it is the metadata. By using this tool decorator, LangChain automatically extracts the function name, reads the doc string that is provided here, and then infers input parameters and the output type. So that information is what the agent later uses to reason, like should I answer directly or should I call one of these tools in order to answer the query. After you've implemented the tools, so we've grouped them into a list here, basically a tools list, and that list is what we pass to the agent, specifying it that those are the capabilities you're allowed to use. Now we see the system prompt here. This is extremely important. The prompt sets the behavior rule for the agent. Here we're telling it very clearly, use tools whenever you're needed. If no tools is required, answer directly. So this instruction guides the model's choice making process. Without this, the model might ignore tools or maybe not call them at all. Now comes the most important part, that is create agent. So the create agent function is where everything comes together. We pass 3 things inside this. First the language model, then the tools, and then the prompt that we've written above. So what create agent does internally is it creates an agent loop. It also enables tool calling, and it manages reasoning, tool execution, and final response generation. So in other words, this function turns a normal LLM into an autonomous choice making system. So the agent now follows this loop. So it basically reads the user input. It chooses whether a tool is required or not. If yes, it calls a tool with proper arguments, and it basically observes the tool output and then generates the final answer. And all of this happens automatically. Now, inside this loop here, we send user input to the agent using the format here. Here, we are explicitly passing messages in chat format. This makes the agent compatible with multi-turn conversations later on. And the response we get back contains all the intermediate reasoning, tool calls, and final output. And that is why we print the particular part only. So that gives us the final answer generated by the agent. Also, to see the full response in debug mode, we've actually implemented a print statement here where we can see which tool was called, what arguments were used, and how the agents reasoned internally. So now we are going to run this. So I'll say, hello, what is your name? So if we see the response, the AI says that I don't have a name, but I'm here to help you with any questions. So if you see the entire response part, you don't see any tool calls inside this here. You directly see an AI message content, the completion tokens, the prompt tokens, total tokens, and things like that. Now if I add, what happens when you add 4 balls into a collection that already contains 5 balls? Now this is basically an addition problem. We'll see if the language model understands the addition scenario and then calls the tools or not. So if we run this now, you can see that when you add 4 balls into a collection that already contains 5 balls, the total number of balls in the collection becomes 9. Well, the large language model can do this too, but I would like to check whether this is done by the LLM itself or by the tool calls that or by the tools that we have implemented here. So if you see here, you see that there is a tool call, we have a function, the arguments 4 and 5 balls are basically passed to A and B in this particular add function, and then the name of the tool that is called is add. So this particular computation or this particular answer is being generated from this tool here and not by the large language model itself. The large language model is taking the help of this tool here. We'll do one more thing. This can also do subtraction. Now if we have a collection of 5 balls in a basket, and if we remove 3 balls from it, how many balls are there now? So again, for this too, it does call the same add function here, but in terms of parameter, the total balls previously were 5, and then we remove 3 balls, which means the parameter b takes the -3 value, and then it basically calls the add function, and we get our result. There are 2 balls left inside the basket. So the large language model is in fact using these tools that we provided to it to answer our particular query, understanding the semantic meaning of our query here. We'll do one more for multiplication. So tell me the product of 10 and 2. It should understand that it is a multiplication problem, and it does. You see tool calls, so we get arguments 10 and 2, and then the function it calls is multiply. So this is how we have now turned our agent, we've now turned our LLM into an agent where it can reason whether to call a specific tool to solve a problem or whether to do it on its own. So the key takeaways from this particular video is that tools use or function calling allows the agent to interact with external systems and access dynamic information. It involves defining tools and clear explanation and parameters that the LLM can understand. And the LLM chooses when to use a tool and generates structured function calls. And agentic frameworks execute the tool calls and returns the result to the LLM. And finally, tool use is essential for building agent that can do real world actions and provide up-to-date information. So the tool use pattern is a critical architectural component for extending the functional scope of large language models beyond their intrinsic text generation capabilities. And by equipping a model with the ability to interface with external software and data sources, this paradigm allows an agent to perform actions, execute computations, and retrieve information from other systems. This process involves the model generating a structured request to call an external tool whenever it identifies that doing so is important to fulfill a user query. And frameworks like LangChain offer structured abstraction and components that facilitate the integration of these external tools. And these frameworks manage the process of exposing tool specification to the model and parsing its subsequent tool use request. And this finally simplifies the development of sophisticated agentic systems that can interact with and take actions within external digital environments. So I hope the concept of tool use is clear to you. If you have any questions, feel free to comment down below and I'll try to help you out. And now I'll see you in the next video with some new topic in this Agentic Masterclass.